optional. So, but still, I think 94 people have registered for the course. That's good actually. And at present, how many are joined in the MS team? So it's around 67 or 68. Okay, fine. Maybe the first class, so it is going to be a little bit delayed. So let me introduce myself in a very brief manner. Okay, so I am Dr. Kamal Krishna Beda, assistant professor in the Department of Civil Engineering. Okay, and I did my BE from Jadavpur University, and then I did my master's from IIT Roorkee, a specialization in structural dynamics in the Department of Earthquake Engineering, and then I finished my PhD from IIT Bombay, okay, in the specialization in structure. And also in between BTech and MTech, I worked for 4 years in the industry. That's Reliance Infrastructure Limited. That is basically a site related work. Okay, civil construction related work. Okay. So that's basically my academic and industrial career, and my research works mainly focus on the dynamics and vibration and the related issues and control of vibration. So if there is vibration, there should be control strategy, right? So, since this is I think this is the first course on vibration you are maybe are introducing, and before that maybe you are in during class maybe I don't know 11th or 12th, you may be introduced with the simple pendulum system, right? The oscillatory system, simple oscillations. Okay. So, since this is a kind of a new topic, like you see, because whatever you have studied so far is basically statics, not the dynamic, right? Whatever under the statics notes, what uh, is happening to the structures or a system that you want to find out, that you have done. And this is a little bit different from that thing. Okay, and obviously you understood since it is a dynamic problem, dynamics, so it will be more involved. And also I think you have a little bit studied dynamics in during your mechanics, maybe statics and dynamics. Okay. So that will also be helpful to you. Okay, so this is an basically introductory or elementary level subject. Okay, not subject, sorry, I mean the course is elementary level. The subject is very vast and it can go deeper as you can. Okay, and I hope you all will be follow this subject with interest, and it is a bit mathematically. You will find that there are a lot of equations, a lot of expressions. You have to solve some differential equations, but believe me, if you study a little bit hard and show interest from the beginning, okay, then you will find this subject very interesting. There will be no doubt about that. Okay, it will be very interesting. Okay, I request all of you to please be in the mute mode. Okay. If you, unless you have any questions or doubt, then you can ask me. Okay. Otherwise, please be in the mute mode. Okay. And so my suggestion will be to whatever I am teaching and each classes. So please follow that thing from any books or from my note. Okay, or from any other resources. There are a lot of resources nowadays. On that day itself, don't keep it for the some later on stage. They, okay, sir is taught little bit amount, this is very easy, I'll do it after 3 or 4 classes. So that actually what will happen, it will create a lot of problem for you, because you are not studying this subject only, right? There are so many other subjects also, so you have to cope up with those also. Okay, so if you do it regularly, then you will find this is simple. I mean, not that much difficult. Okay, otherwise you will feel later on stage, oh, this is too mathematical and sir is not able to explain it, or I am not able to understanding it, these things, it is very difficult subject. Okay, and you will lose interest in the subject. This is actually in general thing which is applicable for all the subjects, but I am specifically telling for this subject. Okay, because if you go for the higher studies also, and I hope some of you will go for the higher studies, and you do the structure in the specialization with structural dynamics as your research topic. Okay, so if you want to work on that, so this is basically a stepping stone. This is basically the foundation block that you have to need to be set up properly. Okay, so that the things I can talk about. Okay, and since I am taking the master's courses also of the same subject, basically that is not elementary structural dynamics, that is structural dynamics. So sometime maybe I will be a little bit on the tougher side I can go, but anyway, the question, don't worry about the question and exams. That will be much easier if you follow the what I am teaching in the classes. Okay. So today is the first class, so I'll just briefly introduction part, maybe little bit I'll start. But before that, I'll request all of you to just little bit come on the video mode and just introduce yourself, from where you belongs and what is your what's called favorite subjects or how you like structures or whatever. Okay, so just briefly introduce yourself, come on the video mode, and then you can go to the switch off your video later. Okay, and actually most of the part will be not in the video mode, but just for introduce yourself, just come to the video mode and uh, introduce yourself. Okay, by roll number wise you can start. Yeah, please. Roll number wise you can start. Whoever is not there in the next one, you can do it. No problem. Yeah, please.
Good morning, sir.
Yeah.
So my name is Abhishek Dadich. I am from Udaipur, Rajasthan, and my interest is in mainly in the mathematics part.
Okay, fine. Next, continue. I mean, the next person. Whoever. Because there are a lot of people, so it will take time.
Hello, my name is Abhishek. I'm from I'm basically from Kerala, but right now I'm settled in Chennai. And my favorite subject is like everything which deals with structural engineering is my favorite. So yeah, that's it about me.
Okay.
Good morning, sir. I am Aditya. I'm from Kerala and I like mathematics.
Yeah, please continue. Don't wait. If the next one is not there, you can next to next can. Let's continue. Continue. Whoever is the next. Yeah, please. Please introduce yourself. Come on. Only three. I think three people has done only. Yeah, who is next? Or no one is next. You are not audible. Speaker, I think you are muted. Please.
Hello.
Yeah.
Hello, sir.
Yeah. Tell me.
Okay, sir. Sir, I am Amit Vikram, and I am currently staying in Lucknow. And my interest mainly lies in mathematics and how we understand the concepts of nature and various structures or various things in civil engineering by mathematical equations is my favorite portion in this. Thank you.
Okay, continue. Please continue. Don't waste that much time. Okay. Next, please.
Good morning, sir. This is Jayashree from Chennai. Structural analysis is my favorite subject, sir. Thank you.
Good morning, sir. This is Apur. I'm from Madhya Pradesh, and my favorite subject is environmental engineering.
Good.
Good morning, sir. I am Ashwin Srinath from Chennai. My favorite subject is structural analysis and related topics.
Good morning, sir. My name is Samit Turada. I am from Nepal, and my favorite subject is drawings. Mainly. Thank you, sir.
Hello, sir. My name is Yuvraj. I'm from Vellore. So I like doing calculations and trigonometry in math. So I choose structural engineering.
Good morning, sir. I'm Bhavya. I'm from Telangana.
Please
And
come in the video
I'm
mode.
in.
While speaking, please come in the video mode.
Yes, sir. I'm on video.
Okay.
So I'm interested in mechanics, topics related in physics.
Yes, next. Please continue. Whoever is the next.
Hello, sir. I am Dinesh Kumar from Salem, Tamil Nadu, and I'm basically interested in all civil engineering subjects.
Okay, next, please. Next. Be fast. Little fast.
Hello, sir. This is Dilraj Sani. I'm from Rajasthan. I'm interested in engineering mechanics.
Also, this is Ilamuyi from Turkey. I'm interested in computer language and building planning.
Good morning, sir. I'm Ganesh Aravind from Dharmapuri, and I'm in structural.
Hello, sir. I'm Hari Govind from Neyveli, Tamil Nadu. My favorite subject is geotech.
Yes, next, please. Yes, please. Next.
Good morning, sir. I'm Nirbhay Singh from Jammu and Kashmir, and I'm mainly interested in fluid dynamics and in structural dynamics, and mainly focus on isolation, low frequency isolation. Thank you.
Good morning, sir. I'm Sharan Balasubramanian from Vellore district. So I find myself interested in structural engineering and geomatics engineering. In structural engineering, I would like to learn more about probabilistic structural mechanics.
So, hello, sir. I'm Ram Prasad from Madurai, and my interest lies in structural engineering and transportation.
Good morning, sir. My name is Rajneesh Meena. I'm from Rajasthan, currently staying in Tamil Nadu, sir, and I like maths.
Yes. Anybody else? All is done or what?
Hello,
Yeah.
sir. I'm Hridyansh Stogi from Uttar Pradesh, and I'm interested in geomatics and structural engineering.
All done? Anybody left? They can introduce the whoever is there. Anybody else remaining?
Hi, sir. I am Mugil from Coimbatore, Tamil Nadu, and I'm interested in structural analysis.
Yeah, please quickly introduce the other people. Please.
Hello, sir. Myself Sudarshan from Tamil Nadu, Namakkal. I'm interested in concrete technology.
Good morning, sir. My name is Varshini and I'm from Chennai. My interest lies in fluid mechanics.
Hello, sir. Myself Kantesh Kumar, and I am from Bihar. I am interested in geotechnical engineering.
Good morning, sir. Myself Lokesh from Neyveli. My favorite subject is mathematics.
Good morning, sir. I am Hrithik Roshan. I am from Tiruchirappalli, and my favorite subject is structural analysis.
Good morning, sir. I'm Tarek from Dhaka, Bangladesh. I'm interested in construction and structural engineering.
Hello, sir. My name is Dashram Prince Singh, and I am from Manipur, and I'm interested in mathematics.
Good morning, sir. I am Sivraj Patil from Bihar. I am interested in environmental engineering.
Good morning, sir. This is Tirth Raj from Barmer, Rajasthan, and I like structural engineering.
Good morning, sir. I'm Sanjeev from Neyveli, Tamil Nadu. I don't have any specific favorite subject. I love all three subjects. Hello, sir. Myself Amish, and I like to do the mathematics problem, and I am from Neyveli.
Good morning, sir. This is Rakan from Tirupur, Tamil Nadu. My area of interest are drawing and design.
All done, right? Okay. So I think someone has messaged that I have not what is called, I have not added them in the team, so that's why they are not able to join. But believe me, so the 94 students that I got, the list of students I got in the MIS, so I just downloaded the names and I included it, all of the 94 students. But if other than anything is there, then I cannot help right now. But just give me the name later on, the CR you can give it, then I can add it to them. Okay. But whatever students I have added here is based on the list, the registered student list available in the MIS. Okay. That's all. Okay. So today let me discuss about the introductory part. Okay. Let me share the PPT first. Just a minute. What is this? Is the slide visible to you?
Yes, sir.
Yes, sir.
Yes.
But I think it is small, right? Or is it the slide is bigger? Why it is coming like this? Just a minute. No. Now it is better, right?
Yes, sir.
Okay. Okay, so today is the introductory class. Okay, so basically you see from the beginning of the human development or other things. So people are fascinated about how, not only structure, how a system or a body, how it is moving, its movement, and what causes this movement. So that fascinated the human life from the beginning. As you can see, as I have written in the first para, the study of relation between the motion of the physical system and the forces causing the motion is a subject that has fascinated the human minds in the ancient times. Okay. So basically, whenever people are seeing that under something is happening to system or structure, it is deflecting, it is distorting, or it is even collapsing also. So there is some force or something is acting on that. There is some cause, right, due to that this thing happening. So what is the cause it is, and how it is, and what manner it is affecting, so that the system behavior is like that. So that is the fascination thing. Okay. So initially Aristotle tried to find out the relation. That means basically the force and the displacement relation basically. Okay. In terms of the dynamic system I'm talking about. Okay. So but he is unable to do that at that time. But then later in the Galileo and the Newtons are the pioneer who has formulated those that relationship. Okay. The force displacement relationship for a dynamical system in a correct manner. Okay. So since we are going to study the structural dynamics basically, right, with its elementary part or the introductory part. So basically we'll study the vibration of the structural system, that's all. So what is vibration? Can anybody tell me what is vibration? What is vibration? What do you understood by vibration? Okay, is body is vibrating or anything like that? What does it mean? Okay.
So time dependent displacements.
Yeah, time dependent displacement, fine. Okay. So that is actually the definition of the dynamics. Okay, dynamic means is a opposite to static. So that is statics is not time independent. I mean there is the time independent and dynamic is the time dependent. So in the dynamic, you are right. In the dynamics definition is basically what you told. So here the forces as well as the its responses obviously are time dependent as opposed to the statics. Okay. So vibration is basically in the terminology is majorly using the mechanical systems or other things. Okay, and we structural people use the structural dynamics like those things. Okay, so vibration is the motion of a body which repeats. It's a repeating motion. That is a oscillatory type. Okay, so oscillation motion about a certain equilibrium position. That's the vibration. Okay. So in structural dynamics, what are you going to study? So in structural dynamics, you're going to study the vibration of the structural systems. Okay. Basically, broadly speaking, the structural system can be civil system, not only civil structure like bridges, buildings, okay, towers, okay, water tanks, or many others. But also, it can be involved with the machine type structure, machinery structures like for mechanical system, okay, and then also aerostructure. Right? For the aerospace people study the aerostructure, right? Okay, they like aircraft wings, aircraft body vibration, those types of things. Okay, so that can be many things. So structure not only means the civil engineering structures. Okay, so that need to be kept in mind. Okay, so that is the thing. So as I told, the vibration is that so any motion that repeats itself after an interval of time. That is the oscillation about a certain equilibrium position. So oscillatory motion basically, like a simple pendulum. The best, the easiest example is the simple pendulum. And dynamics is defined by simply the time varying. So the dynamic load will be as well as the response. So the load is also time varying, the response will also be time varying, and there will be so its magnitude, direction, and or position etc. can vary with time. Okay. So in the dynamics of structure, what are you going to study? And study the vibration of the basically the structure. So vibration means obviously what is causing them, how to measure them, how to analyze them, and what are the effects is imparting on the structures. That's all. Okay. So you see, the excitation is like an input. Okay. The input is coming to the structures, and as an output, you are getting the response. Okay. So the response can be what are the response? Can you tell me what are the responses that you are going to see or measure, either measured or if it is experimental, then it is measured, and if it is analytical or numerical you are doing, then you just solve with some equations and then just get the response. Responses. What are those responses? What is the response quantities can be?
So displacement, and there can be structure failures.
Yeah, that is the later thing. So the responses will be why you are saying only displacement, because you have studied only the statics, that's why you are saying displacement. So here the velocity and acceleration will be also important, right? So there will be velocity and acceleration. So it's a time dependent thing. Okay. So displacement, velocity, acceleration, and from that we will find the time varying forces. And since our ultimate aim is what, right? So to find out, in order to design that, what is the maximum forces it is subjected to, right? Or what are the maximum displacement it is. So I have to design such a manner that the displacement is limited. So you have to find out the peak value, right? Peak value of the displacement or peak value of the acceleration, right? Okay. Why acceleration is important along with the displacement? Can you give an example where the acceleration is important? We need to limit the acceleration. Any idea? Okay, no problem. It is like a very tall story building, right? Like 50-story, 100-story building. So if you stay at the top floor and there is a wind blowing, you will find the it is like a swinging. Okay, it will be like a swinging. Okay, and it will be discomfort for those things. So this is just one simple example for the acceleration problem. And also, let's say in a floor there is some delicate instrument is lying, right? Like some medical instrument or some other very delicate instrument is there. So their displacement is also a problem, and also for the acceleration, even if it is a small amount, that will create a problem or damage to the those type of system. Okay. So let us see what are the causes. It is basically the dynamic loading, right? So what are the characteristic and the source of the typical dynamic loading? So as you understood that it will be time value, right? Okay. So broadly saying, it can be classified into two categories. Okay. Let me just open my pen tab. Okay. Right. What is this? Okay. Yeah. So you see, broadly speaking, it will be classified in the two category. One is non-periodic and another is the periodic. Okay. So periodic means, as the name suggests, it will repeat after a certain interval time. The loading. So this is basically the time axis. Okay. This is basically the time axis, and this is the force. So force F as a function of t, and the y-axis is the force as a function of t, and x-axis is the time. Okay. So you see that as the time, it is varying, right? Not like a static load. Just a if I give an example, like a spring and mass system. Okay, so let's say there is a spring and there's a mass system. Okay, the static load can be just giving a load P, not varying with time. So as you already are aware that if the spring stiffness is K, right? So you know the spring stiffness, right? So that then the displacement of this mass in the downward direction. Okay, so it will be just, if I neglect the weight also, then it will be, if the displacement is delta, so it is nothing but P by K, right? And in static, basically you solve this equation, that is P equal to K into delta. Okay, you solve it. Okay, so if it is a single system like this, then it will be all the single quantities. Okay, if it is a multiple system, then many other things is there, then it will be all this matrix. This will be vector, this will be matrix, this will be vector. Okay, that you will study in later on when you do the matrix structural analysis. Okay, maybe in the third year or fourth year, maybe. Okay. Anyway, so that this you know, right? So the displacement will be the force divided by the stiffness of the spring. Okay, and stiffness is the force required to produce the deformation, basically, right? Okay. So you see, so this is repeating after a certain time, as in the case of this. And what are the what could be the source for this type of loading, periodic loading? Like this type of periodic loading can be obtained from the unbalanced rotating machine in a building or an overhead foundation. Okay, let's say there is a foundation is there and a rotating machine is there, so it will produce this type of loading. Okay, and this is the example for this kind of loading. This is also periodic, but you see, this is a special case of periodic which is called the harmonic. Okay, as you will see later. Okay, the system under harmonic loading. Okay, so this is harmonic. Okay, so either this is following the sinusoidal or cosine function. So this is either sine function or cosine function. What kind of function this is? In the figure it is so sine or cosine?
Sine.
Sine function. Okay, so if the cosine also, it is also called harmonic. Okay, but both are periodic, but this is not harmonic. Remember that. Okay, this is not harmonic, but it is repeating itself. After starting, even this can be like this also. Right? This type of thing also. Okay, but this is not harmonic. Okay, although it is repeating after certain time interval. And then there is non-periodic. Okay, so non-periodic, you see, it is you see the first example. So you see just there is a force and then it quickly vanishes. Okay, so it is a pulse type of loading. This is also called the pulse type of loading. We will see how to find out the responses against each of this kind of forces. Okay, specifically our more interest will be because since this is introductory course, we'll do mainly on the harmonic type of loading and also pulse type of loading. So pulse type of loading example may be the blast loading. Okay, sudden impulse. Okay, and it just vanishes, it is not continuing. Okay, and then there is a arbitrary type of loading. You see, random. It's random nature. So this nature is random nature. Okay? It's very random nature. Okay, there is no deterministic thing is there. It's called probabilistic, right? So this type of loading is called the probabilistic loading, like earthquake. Okay, or random wind loading, right? Turbulence, due to turbulence. Okay, so it's a fluctuating component, right? You see, it is just varying. There is no, it is neither periodic, non like a pulse type of loading also. So it is just a random nature. Okay. So these are the typical characteristic of the loading, and this is the typical sources. Okay, for the dynamic loading. Okay. Okay. So as I just told about that, so we can classify in two category mainly based on whether we know the load beforehand or do not know. Okay, the nature of the load, basically pattern of the load we know or do not know. Okay. So the one is called the deterministic and one is called the probabilistic. Probabilistic is also sometimes known as the stochastic or the random. Okay. So in the present study or in the course, we'll only talk about the deterministic type of loading. Okay. So that means we know the what is called the time is basically the basically if you plot this, as I told, this is time and this is, let's say, function force as a function of time, so you know it whatever it is beforehand. Okay. So the excitation and known function of the time. Okay. Like as I told, the rotating machine induced vibration. Okay. And the probabilistic example is the earthquake loading. Okay. But for simplification, sometimes the earthquake loading or wind loading also can be treated as an indeterministic manner. Okay. Then as I told, what the response, it can be deflection, displacement, deflection, and then velocity, acceleration, and then there is internal forces you have to find out, then stress, strain, all those things can be obtained. Okay. Okay. So objective, what are the objective of the dynamic analysis? As I told, you have to find out. So there is some system is there and some time varying excitation is coming into that. Okay. So you have to find out what are the displacement, what is the velocity, and what are the acceleration, and then there is internal member forces. Time history. What do you mean by time history? Time history is the basically, let's say, the simple the spring mass system. Again, I am talking about, let's say this is the spring is there, this is another mass is there, this is the stiffness is there. Okay, we'll discuss about these things, what is spring mass and how to develop the equation of motion. Will come into that. And let's say it is subjectivity force of ft, time varying force. So obviously now I want to find out what its response, right? How it is response. So the response is, let's say, xt. So xt, let's say the response, and this is, let's say, the force. Okay, all are time varying. Okay, so this is the spring stiffness and this is the mass of the body. It can only move in this direction only, that x direction only, let's say. So that if I plot the response time varying, so let's say it will be something like this. Okay, let's say something like this. Okay, so this with time versus that xt, that's what this is called the displacement time history. Okay, similarly, if I plot x derivative of the x, okay, time derivative, then it's called the velocity time history, and double derivative with the acceleration time history. So this is called time history, or sometimes we also call the time trace. Okay. So from the time history, as I told, so you are more interested on the peak value, right? What is the maximum? Okay, because that will be the governing thing, right? And the mean value, frequency of the response parameter, those are also important, as you will see later. Okay. Okay, so you can see here what are the static, the major difference between the static and dynamic problem. We'll discuss in the next slide also. Okay, so dynamic problem is time varying in nature in both the loading as well as the responses. Okay, as opposed to the static problem actually, where neither force is varying nor the displacement is varying with time. Okay, like this, let's say cantilever beam. So you have given a load P on the tip end, right? By that means at the free end you have given. So you know it is the length is the length of the beam. It is the PL cube by 3I, right? Or anything else? It is PL cube by 3I. Okay, so that is the deflection. So that's fine. And where EI is the flexural rigidity, right? E is the modulus of elasticity and I is the moment of inertia. Okay. So that is fixed. There is no, it is not varying with the time. But here, if the load is varying, so it is the displacement also is varying with the time. The response basically is varying with the time. Okay. So therefore, I mean, it is intuitively we can say that the dynamic analysis in general it is more complex and obviously time consuming phenomena as compared to the static analysis, right? You see, so as I can told earlier, or from the spring mass system also you can think about that. Okay, so you see on the left hand figure that I showed just a simply supported beam with a P loading acting, which is not time varying, just a static load P. So the internal moment, I mean that's parameters basically, that the parameter that we are interested on, that is the moment, shear force, and obviously is deflection. So those are depends upon the P, and you can easily compute it by the equilibrium approach that you have done. Okay? The static equilibrium approach of the forces, principle of static equilibrium. Okay. But in the right hand side cases, you see, since the forces are time varying, so it not only depends upon the P forces, okay, but also there is additional forces coming into the picture, that's called the inertia forces, and that generated due to the acceleration of the body. Okay. So due to the time varying nature of the forces, there is acceleration induced in the body, and that due to acceleration there is an inertia force which opposes those acceleration. Okay, we'll see when we'll develop the equation of motion, right? So that's why I'll tell you. So basically, as I told earlier, right, again we are going back to the spring mass system. Okay, that is basically the simple system. I showed here beam because you are used to the beam. Okay, either in the horizontal direction or it doesn't matter, in the vertical direction, I mean whatever direction it is. So let's say M is there, spring is K. So if I put a force, static force F, okay. So let's say it can go in this direction only. So and the displacement is only X. So then I can write X equals to what? F by K, as I already told, right? So basically my equation is Kx equals to F, right? Static case. But in the dynamic case, it will be Kx equals to Ft, or I have used here Pt anyway, no problem. Ft. So it is some additional thing is there. Okay. So this is basically static equilibrium, right? Static equilibrium, and this is basically called the kind of dynamic equilibrium. Okay. We'll see how to formulate this. So, and since dynamic equilibrium, or in other terms, is called the equation of motion. Equation of motion. Okay. We'll discuss this, how to develop this. Just it is giving a brief idea about that. So there is an additional time. Remember that term coming to the picture due to the acceleration of the body, which is opposed by the inertia forces. Okay. So here one term will come. There is nothing but inertia as the mass into acceleration. M into x double dot will come into the picture. Okay. So that is the basic major differences here in the static and the dynamic problem. Okay. And you see, if these inertia forces are quite substantial, okay, then you have to treat the problem as a dynamic problem. But in some cases, you may find out that, or if you find out that, suppose let's say you are handling a problem and you find out that the inertia forces are much less, negligible quantity, then you can treat it as an approximately as a static problem. Okay, sometimes that's called also the quasi-static problem. Okay, right? So I think the second para I have written, if the motions are so slow, yeah, it is so slow, right, that the inertial forces are negligible. Okay, and then the analysis of the response of any desired instant of time may be made by static structural analysis procedure, even though the load and response may be time. Okay. Fine. Now, so I will just stop with this slides and let me see what is the next slide. Okay, that you actually know the simple pendulum thing. So let me talk about that. So as I told, so in a vibratory system, basically dynamic system, so there are basically three parameters are present there. Okay? 1, 2, and 3. You can see here. Okay. Okay. This is a part of the elementary part of the vibratory system. Okay. Okay. So one part is that spring I showed, right? Just a spring mass system, right? So that is the simple system. Okay. So that is the one element, that the spring element, or which is also called the elasticity element. Like how it is elasticity element? Because you see this is beam, right? Beam. So here the no spring is there, but actually beam is providing some stiffnesses, right? Against the deflection or torsion or whatever. So there is some providing some stiffness. Right? You know EI is the flexural stiffness, right? Then what is EA? What is EA? What is EA? EI is the bending stiffness or flexural stiffness. What is EA? What is GJ?
So flexural rigidity. EA is flexural rigidity.
Which one? EA or EI?
EI is flexural rigidity, sir.
Yeah, flexural rigidity or bending rigidity. What is EA?
So compressional or tensile rigidity.
It's called axial. Axial stiffness or axial rigidity. What is GJ?
Torsional.
Volume.
Torsional rigidity. Correct. So then basically it has some stiffnesses. Okay, so that actually with the simple system I am showing as a K, like K and M. So K is the stiffness of the spring. Okay, so there is some one element which stores and what it does, it stores the potential energy, right? The spring stores the potential energy. Okay, what is this potential energy stored in a spring? Let's say there is a spring is there, and I have deformed by an amount X, and let's say its thickness is K. So what is the potential energy stored in the spring? Can you tell me?
Half kx squared.
Half kx squared. Fine. Okay. So there is the half k into basically the relative displacement. This x is the relative displacement. That is, in this case, it is x minus 0 whole square, right? Because this end is not moving. So this is the thing. So basically, if I write like this, the two end. So if this is moved by x1, this is moved by x2. So you have to write it half k x2 minus x1 whole square. Correct? The relative. Then as I already told, since it's the dynamic problem, there will be additional term, that is the storing the kinetic energy. Okay, so it should store the kinetic energy. Okay, that's the mass or inertia property that I am talking about. Okay, and there is additional things coming into the picture in the dynamic system. Okay, so that's called the damping properties. Okay, what is the damping property? So it is the property through which the energy is dissipated. You see, Let's say just take a scale, a flexible scale, okay, and just you just vibrate it one side. I mean, just pull it and just leave it. You see it is getting vibrated, right? And after a certain time, the vibration is getting dies down, right? So what is that phenomena happening? Why it is going to die down? Okay. So that mechanism is called the damping mechanism. Okay. So there is energy dissipation, because you see when you are giving some disturbance to the systems, you are providing some energy basically. So right. So that energy is somehow dissipating. Otherwise, so why it is coming to the rest? I mean, its original equilibrium position. Okay. So actually, this is a complicated phenomenon. Actual how this is damping a thing is coming. Okay, but we will through some simple assumptions. Okay, this can be treated in our equation of motion. Okay, or the dynamic equilibrium equation. Okay, like the viscous damping. It's called that we'll see later. It's called the viscous damping, which is velocity proportional. Okay, viscous damping, which is velocity proportional. We'll see later. Okay. Maybe you may not be able to get what I'm telling right now. So we'll see when we write the equation of motion. Okay. So this is the three major parameter. One is the spring parameter, which store the potential energy, and then another is the mass or the inertia thing, which store the kinetic energy. So what will be the kinetic energy? You have a mass m with velocity v if it is moving, then
half mv square.
half mv square. So if x is the displacement, then x derivative of x time derivative, that is dx by dt, is the velocity, that is half m x dot square. So half m x dot square. So this is the kinetic energy stored by this mechanism, by this spring mechanism. It is showing the potential energy, and there is the certain thing which we cannot see, right? There is nothing like this, but there is an energy dissipation mechanism happening. Okay, that's called the through damping. Okay, that's why it's come to its original position. Okay, otherwise it will continue to vibrate. So we'll study this thing. We'll just ideally assume that there is no damping. When we solve the equation of motion, so we'll ideally assume that there is no damping. But although in all physical systems there will be damping. Okay, so so that it vibration is coming down, okay, up with time. Now how fast it will go down, that depends upon the amount of damping present in the system. Obviously you are intuitively getting, right? Okay, so we'll see if the damping is removed, so it will continue to vibrate. I mean, theoretically we will show that. Okay, so what is that? It is written in the second part. The vibration of the system involves the transfer of its potential energy to kinetic energy, or kinetic energy to potential energy alternatively. So you can think about the simple pendulum system, and you see there is actually a conversion of the energy from kinetic to potential, or potential to kinetic. Okay, if the system is damped, some energy dissipated in each cycle of vibration and must be replaced by an external source if the steady state vibration is to maintain. That means what I am saying, that if you do not apply any other external forces, just it is pull, I mean, you give some initial disturbance and leave it, then after a certain time it is bound to come out to its rest position. Okay, unless you continue to forcing it and you want to maintain the steady state vibration. Okay? So steady state thing, all those terminology we will discuss later. Okay? And it will be clear to you in a simple manner. So I'll stop it here. Okay, and as far as the course content that I will share with you, but you can just syllabus content you can see from your BTEC's whatever syllabus you have. Okay, so that I am going to cover. Okay, as I told, I am since I am going, teaching also the master's courses also, so sometimes I may go a little bit deeper, but that's okay. The same subject actually, not that. So the only the title is different. That is structural dynamics, and this is elementary structural dynamics. Okay, the books that you can follow is that these books you can follow. Okay, structural dynamics for Claff and Pengine. Okay, then Mario Paz. Mario Paz is also a simple book. You can follow mechanical vibration SS Rao, which is again simple and little detailed. It is written, and some example also you'll find, many example you'll find in Rao. In Claff and Pengine you may not find that much examples. Okay. Then this book also is very good actually. Okay, but you may find little difficult, but it's a classic book. There's elements of vibration analysis, Leonhard Meyrovich, and this is commonly followed in the mechanical and the aerospace people by. Okay, this is also a good book. I mean, but it actually not elaborated that much. I mean, it will write 5 sentences in one sentence, but that sentence has meaning in a proper manner. It is written. Okay? So if you could understood these books, and it will be good. Okay. Then there is a A.K. Chopra book on dynamics of structure, but this book you can refer. But actually, this book is specifically intended to earthquake engineering. Okay. So those who are interested in earthquake engineering research and study, so this book is specifically intended for the earthquake dynamics of structure. This A.K. Chopra book. But you can refer There is no issue there. So I think these soft copies are easily available for all these books. You can download it, and if you do not find, then I may upload in the university. Okay, so that's all. Finish the first class. We'll meet tomorrow. I think our classes are Monday, Tuesday, and Wednesday, right? 9:30, 10:30. Sorry, 10:30, 11:30, and 12:30 respectively. Okay. So I think one CR is contacted with me. So whoever, if anyone is there, other CR, then you can just give your contact number, and if you have any doubt or anything regarding what I am teaching, so then you can contact me beyond the classroom also. Okay. Yeah. Thank you.
Thank you, sir.